When examining one-line diagrams, you'll often encounter circuit breakers labeled with two values such as 2500 F 2500 at. Understanding what AF and at signify is crucial for interpreting the breaker's function and capabilities within the electrical system. AF stands for amperage frame. The amperage frame represents the maximum current that the circuit breaker is physically designed to handle. It defines the breaker's overall size and its ability to dissipate heat effectively. The amperage frame dictates the highest possible trip setting available for that particular breaker. A larger amperage frame generally indicates a more robust breaker capable of handling higher fault currents. The amperage frame is determined by the manufacturer based on the breaker's construction and materials. It's a fixed value and cannot be adjusted in the field. The amperage frame essentially specifies the upper limit of the breaker's interrupting capacity. Exceeding the amperage frame can lead to breaker failure and potential safety hazards. AT stands for Ampere Trip. The Ampere Trip setting refers to the specific current level at which the circuit breaker is designed to trip or open the circuit. This setting determines the breaker's sensitivity to overcurrent conditions. The Ampere Trip setting is often adjustable, allowing for customization based on the specific load requirements of the protected circuit. The Ampere Trip setting is crucial for preventing damage to equipment and conductors due to overloads or short circuits. A lower Ampere Trip setting provides greater protection against smaller overcurrents. A higher Ampere Trip setting allows for larger temporary overloads without tripping the breaker. The appropriate Ampere Trip setting should be carefully selected based on the ampacity of the conductors and the operating characteristics of the connected equipment. The Ampere Trip setting is typically indicated on the breaker's nameplate or adjustment mechanism. Different types of trip units are available, offering various tripping characteristics such as instantaneous, short time, long time, and ground fault protection. Some breakers utilize electronic trip units, which provide more advanced features such as adjustable time delay settings and waveform analysis. These electronic trip units allow for precise coordination with other protective devices in the electrical system. Proper coordination of Ampere Trip settings is essential to ensure selective tripping, where only the breaker closest to the fault opens, minimizing disruption to the rest of the system. Incorrect Ampere Trip settings can lead to nuisance tripping or failure to trip under fault conditions, compromising the safety and reliability of the electrical system. Consider a scenario where a circuit breaker is labeled 2500 F 2500 at. This indicates that the breaker has an amperage frame of 2500 amps and an Ampere Trip setting of 2500 amps. The breaker is physically capable of handling up to 2500 amps continuously, and it is designed to trip when the current exceeds 2500 amps. Now, let's consider a different example, a breaker labeled 2500 F 2000 at. In this case, the amperage frame is still 2500 amps, but the Ampere Trip setting is 2000 amps. This means that the breaker is physically capable of handling up to 2500 amps, but it will trip when the current exceeds 2000 amps. This lower trip setting provides greater protection for the connected circuit. To further illustrate the importance of understanding AF and AT, let's consider a scenario involving a motor circuit. Suppose a motor has a full load current of 150 amps and the NEC requires the overcurrent protection device to be sized at 125% of the full load current. This would result in a required breaker size of 187.5 amps. In this case, a 200 F200 breaker might be selected. The 200 AF amperage frame ensures that the breaker is physically capable of handling the potential fault current, while the 200 at Ampere Trip setting provides the necessary overload protection for the motor circuit. If a breaker with an insufficient amperage frame were used, it could overheat and fail under high fault current conditions. If a breaker with an inappropriate Ampere Trip setting were used, it could either nuisance trip during normal motor starting or fail to trip under overload conditions. In addition to amperage frame and Ampere Trip, other important breaker characteristics include interrupting capacity, voltage rating, and number of poles. Interrupting capacity refers to the maximum fault current that the breaker can safely interrupt without sustaining damage. The voltage rating indicates the maximum voltage at which the breaker can be used. The number of poles refers to the number of circuits that the breaker can protect. It's important to select breakers that are properly rated for the specific application. Using a breaker with an insufficient interrupting capacity can lead to catastrophic failure during a fault. Using a breaker with an incorrect voltage rating can also result in safety hazards. The NEC provides detailed guidelines for selecting and installing circuit breakers. NEC Article 240 covers overcurrent protection, including requirements for breaker sizing, interrupting capacity, and coordination. NEC Table 430.52 provides guidance on selecting overcurrent protection devices for motor circuits. NEC Section 110.9 covers interrupting rating. NEC Section 110.10 covers circuit impedance, short circuit current ratings, and other characteristics. When working with electrical systems, it's crucial to consult the NEC and other relevant standards to ensure compliance and safety. Qualified electricians and electrical engineers should be involved in the design, installation, and maintenance of electrical systems. Proper training and experience are essential for working with electricity safely. Always energize circuits before working on them and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Electrical hazards can be deadly, so it's important to take all necessary precautions. In summary, AF represents the amperage frame, which is the maximum current the breaker can physically handle. AT represents the Ampere Trip, which is the current level at which the breaker trips. Both values are crucial for selecting and applying circuit breakers correctly in electrical systems. Understanding these concepts ensures the safety and reliability of electrical installations. Correct interpretation of AF and AT values on circuit breakers is a fundamental skill for anyone working with electrical systems. By understanding these ratings, you can ensure that the breakers are properly sized and applied to protect equipment and personnel from electrical hazards. Always consult with qualified professionals and adhere to relevant codes and standards when working with electrical systems.